Now it is a demo, but before this demo part, this is our design. High-level design, not absolutely accurate, but kind of accurate, semi-accurate. If you have kernel driver in operating system, each kernel driver it has only one copy, right? You can run, it's a re-enterable, of course, but a single copy of kernel driver, right? So, can you imagine if instead of single kernel driver, somebody will tell you, you know what? Start many of your drivers that actually use the same SSD and so on and so on and so on. And when they told us about this, we literally started to cry. Say, guys, can you imagine? We have global structure, synchronization, one of our instance of our driver, two global mutex, and after that it crashed. And after that, can you imagine, right? Yeah. From single driver to have completely different, with completely different address space and so on. It's horrible. Even though actually they gave us shared memory, it's horrible. So what they say, okay, they told us, we'll define for you Daemon. It's a user mode process. Is it the right level for discussion?
Yep.
It's okay? Okay. Okay? It's a user mode process that has a run single copy of our caching engine. Filter, IO filter, literally it's actually running here inside each virtual machine with all this encapsulation. Blue, it's actually wire software. Run inside each VMX, but it's very light. What it does, it intercepts requests and transfer this request to the daemon. That's only what they did. And daemon tell, for example, do for me something, send completion. How to minimize the latency for this communication? They gave us shared memory across really shared memory, mapped into each address space for each instances and daemon. So we have a messages queue with few microseconds delay to deliver message from instance to the daemon. Daemon always runs. It's automatically started and automatically restarted. They have watchdog. If daemon is dead, they restart daemon. So it's always on. By the way, it's a big problem to handle daemon crash and instance crash, because it's shared memory, global structure and shared memory, how to recover this. That's a very substantial part of our design, how to recover after that. But much simpler if we would have our caching engine running in each instance. So Daemon has sufficient amount of resources, because Daemon is key point in whole I/O handling. Daemon is used not only for local I/O but also for remote I/Os, replication, data replication. Why we need to replicate data? If it is write-back cache, we must have extra copies of data. In this case, it's 2 copies of data. Actually, that's what happened. When
is the number of copies a user option?
In this moment, no. It's 2. It's how to say, we're in rush to deliver something.
I understand, but you know I'm paranoid.
2 in this moment.
3.
Yeah, understand. Yeah. But in this case, you will utilize SSD not very efficiently. The more copies you have, the less efficiency for SSD.
I can buy bigger SSDs and sleep at night.
Totally agree.
You guys have a 4 terabyte model?
Okay.
What, SanDisk gonna have to sell more?
He twisted my arm.
Actually, I agree. We are talking about 3 copies, but again, It's nothing special here, but again, it's we must release it, and we'll release it very soon.
Crawl, walk, run.
And 2 copies is good enough to start, right? There's no magic behind that. It's fine. Okay, we have 23 minutes only. Oh God! Come on.
Get to the good stuff.
Okay, installation. In this, yes, I have enough time for demo. First of all, 4-node cluster. In this 4-node cluster, you will you'll notice that there is no special policy, which is caching policy. We install our software in a vCenter. It's normal installation from .msi file. And after that, from vCenter, from our GUI, you will see that we install everything on each host simultaneously, downloading our software, our filter, from web server. And now let's see how it works. So 4-node cluster, you see, check that there is no default policy. It's only default policies here. There is no caching policy here. Install our software. Just obviously double click, it's normal Windows installation. This is example when we use Windows virtual server. Now let's configure. Sorry, now let's install. So now our software exists on a vCenter, web server, and install everything from this web server on each host. And you will see this is real time. That's it. The whole installation is done.
Pretty fast.
Our software everywhere. Next is configure our software. Configuration is a really complicated process. First of all, we check that caching device exists. We allow having hosts without SSD, no problem. Software must be there, but SSD might not be installed. We do not require this. So we check caching device. We define caching capacity. And by the way, we check licensing. Licensing is actually in a big data center with multiple clusters. It's a big deal. So we have write-back cache, write-through cache, number of copies of software that a customer bought can be less than number of hosts, or they add host, or host is out. So that's a licensing in a cluster configuration, data center, multi-cluster configuration. It is something. So we require license configuration, identify caching device, identify capacity. Back to your questions, we can allocate less or more space from SSD, sharing SSD with somebody else. We enable write-back cache, write-through or write-back, default write-through, but we enable write-back cache. And after that, we configure all hosts in the cluster. At the very end, we register ourselves as a caching policy. So you can see that everything is done from our GUI. You don't need to switch, for example, to SPBM and say, okay, this is a caching policy. We'll do it programmatically from our side. So that's a lot behind this configuration. So we have 400 gigabyte. Guess from whom SSD? Who is the vendor of SSD? Guess.
Micron.
SanDisk. Okay, 400 gigabyte. We assign enable write-back cache. Configure cache.
You don't need an SSD on each host to install it? But
No, SSD. We cannot programmatically install SSD. SSD must be there. I can tell you FFS should be there.
Okay.
If you can remotely install the SSDs, that would really boost SSD sales.
I'd buy it then.
Qualifying question. the caching software is installed on every node in the cluster. What if there's a node in the cluster that does not have an SSD installed?
In this case, that's perfectly fine. We'll continue installation, but this host will run all VMs in bypass mode.
Okay.
That's it. There is no problem at all. That's
So
an answer? Yeah.
Virtual machine that had caching enabled and it was running on a host that had an SSD, if it migrated to that host without the SSD, it would lose the caching.
Bypass.
Okay.
Spend your money, yes.
Search, and then it moves back to the host that has the SSD. What happens?
What happened? Return to caching in the mode that we need.
Okay.
By the way, one more remark which is important. When you have time, now I see that's very important to have this time here. When we configure cache, it is actually write-through cache cluster-wide or write-back cache cluster-wide. If it is write-through cache, all acceleration will be in write-through mode, no matter what. If it is a write-back cache, you have a choice to start acceleration for virtual disk in write-back or write-through mode. So that's obviously. Let's check that we have a policy installed. Here we are. This is our new policy. Caching policy is installed already. Registered, I would say. So as you can see, we minimize switching back and forth from our GUI to VMware GUI, and actually everything is done from our GUI, from our management, I would say, infrastructure, which is good. We hate to switch back and forth. Performance. I already mentioned several things that switching from kernel, from user mode to the kernel is few microseconds. It is the same process, bottom line. Process in a traditional sense, it's the same address space, just switching to the kernel. Instead of just for regular I/O, all these hops must be done, including file system. We are above. When virtual machine start I/O, it dives into framework, return back to I/O filter. Filter, as I told you already, directly accesses acceleration hardware. There is a fast communication between instances and daemon. We already told you about shared memory. What else is very important? Daemon may start I/O directly from virtual machine address space. Remember, from virtual machine to framework, back to I/O filter, redirect request to the daemon. Daemon start I/O against SSD. If it does it directly, it can do it directly. We can do it directly from daemon. We don't need to ask instance, could you please start this I/O against SSD? It takes time, even few microseconds. 10 microseconds already.
10 microseconds
SSDs
here, 10
coming.
microseconds there. Eventually it adds up.
Hop. Yes, exactly. Yeah, you're absolutely right. So that's why we count, frankly speaking, each 5 microseconds. I don't want to say we count each microsecond, but 5 microseconds and 10 microseconds is already lots of time. So that's why we try to do it, number one, everything in the user mode, we have time. In the user mode, but as fast as possible. Okay.